Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology. Subject code CS3352 Foundations of Data Science, Unit 1, Topic Data Mining, Data Warehousing, Basic Statistical Descriptions of Data. Data mining, it is a process of discovering actionable information from large sets of data. Here the data mining uses mathematical analysis to derive patterns and trends that exist in data. Typically, these patterns cannot be discovered by traditional data exploration because the relationships are too complex or because there is too much data. These patterns and trends can be collected and defined as a data mining modeling. Here, the mining models can be applied to specific scenarios. The first one is forecasting, that means estimating sales, predicting server loads or server downtime. The next one is risk and probability. That means choosing the best customers for targeted mailings, determining the probable break-even point for risk scenarios, assigning probabilities to diagnosis or other outcomes. The next one is recommendation. Determining which products are likely to be sold together, generating recommendations. Finding sequences, analyzing customer selection in a shopping cart, predicting next likely events, grouping, separating customers or events into cluster of related items, analyzing and predicting affinities. The next one is we are going to see the data mining architecture. That means it is a knowledge discovery process. In this knowledge discovery process, here we have going to see the first in the means building up an understanding of the application domain. That means it develops for understanding what should be done with the various decisions like a transformation, algorithm, representation, etc. The next one is choosing and creating a data set. That means the data that will be utilized for the knowledge discovery process should be determined. The next one is pre-processing and cleansing. Using this step, the data reliability is improved. It incorporates data cleaning. For example, handling the missing qualities and removal of noise or outliers. It might be include complex statistical technique or use a data mining algorithm for this context. The next one is data formations. In this stage, the creation of appropriate data for data mining is prepared and developed. Using these techniques, you can able to incorporate dimension reduction, for example, feature selection and extraction and record sampling. The next one is prediction and description. Using this one, what kind of data mining for use? For example, classification, regression, clustering, etc. This is mainly used for the knowledge discovery objectives and also it will be significant objectives in data mining. The next one is selecting the data mining algorithm. In this stage, it incorporates choosing a particular technique to be used for the searching patterns. The next one is evaluation. Using this evaluation, you can able to mine the patterns, rules, reliability to the objects categorized using the steps. The next one is data warehousing. Data warehousing is the process of constructing and using a data warehouse. A data warehouse is a constructed by integrating data from multiple heterogeneous sources that support analytical reporting, structured or an ad hoc queries and decision making. Here we have some characteristics of data warehouse. First one is subject oriented. That means a data warehouse is subject oriented since it provides topic wise information rather than the overall process of a business. For example, sales, promotion, inventory, etc. The next one is integrated. A data warehouse is developed by integrating data from varied sources into a consistent format. The next one is non-volatile. Data once entered into a data warehouse must remain unchanged. All data is read-only. The next one is time variant. The data stored in a data warehouse is documented with an element of time, either explicitly or implicitly. The next one is database versus data warehouse. Here, a data warehouse and a traditional database share some similarities. They need not be the same idea. The main difference is that in a database, data is collected for multiple transactional purpose. However, in a data warehouse, data is collected on an extensive scale to perform analysis. Databases provide real-time data while warehouses store data to be accessed for big analytical queries. Next, we are going to see the data warehouse architecture. Here you have three tier architecture. First, we are going to see the bottom tier. The bottom tier or data warehouse server usually represents a relational database system. Backend tools are used to cleanse, transform, and feed data into this layer. The next one is middle tier. Here the middle tier represents OLAP server that can be implemented in two ways, the ROLAP or relational OLAP model. It is an extended relational database management system that maps multidimensional data process to standard relational processes. The next one is multidimensional overlap directly acts on multidimensional data and operations. The next one is top tier. This is a front-end client interface that gets data out from the data warehouse. It holds various tools like query tools, analysis tools, reporting tools, and data mining tools. The next one is benefits of the enterprise data warehouse. Fast responses, availability, quality, consistency, business intelligence, cost savings, and increased revenue. The next one is basic statistical descriptions of data. It can be used to identify properties of the data and highlights which data values should be treated as noise or outliers. Measuring the central tendency, mean, median, and mode. The attribute x like salary is recorded for a set of objects. Then x1, x2, xn be the set of in observed values or observation for x. Here these values may be referred to as the data set for x. To plot the observation for salary, where most of the values fall gives us an idea of the central tendency of the data. The mean of this set value is x bar equal to sigma I equal to 1 to n xi divided by n equal to x1 plus x2 xn divided by n. Measures of central tendency includes the mean, median, mode, and mid-range. Measuring the dispersion of data, range, quartiles, variance, standard deviation, and interquartile. The measure churches range, quantiles, quartiles, percentiles, and interquartile range are used to assess the dispersion or spread of numeric data. The 5-number summary, which can be displayed as a box plot, is useful in identifying outlines. Variance and standard deviation or also indicate the spread of a data distribution. The next one is range, quartiles, and interquartile range. That means let x1, x2, xn be a set of observation for some numeric attribute x. Here the range of the set is the difference between the largest and smallest values. Quantiles are points taken at regular intervals of a data distribution, dividing it into essentially equal size consecutive sets. Here that the quantiles formulas are IQR equal to Q3 minus Q1. Next one is variance and standard deviation. Variance and standard deviations are measures of data dispersion. They indicate how spread out a data distribution is. A low standard deviation means that the data observation tend to be very close to the mean, while a high standard deviation indicates that the data spread out over a large range of values. Here the formula for the variance of n observation for a numeric attribute x. Thank you.